Okay, so yesterday we did uh, basic basics of straight lines. So we just covered, what is slope. Just a second. Yeah. So we covered what is slope. We saw what is inclination first, and tan of that inclination is the slope. Inclination lies between 0 and 180 degrees, and slope is tan of this. Slope of a horizontal line is 0. Slope of a vertical line is infinity. Slope of a line which is inclined with acute angle to the x-axis is positive. Slope of a line which is inclined at obtuse angle with the x-axis is negative. And slope in terms of coordinates of 2 points. This we discussed, y2 minus y1 by x2 minus x1. And comparison of slopes of two lines. If two lines are parallel, the slopes will be equal. If two lines are perpendicular, the product of slopes will be -1. So these are the things we discussed. And finally, angle between the lines having slopes m1 and m2 is given by theta. Then tan theta is m1 minus m2 by 1 plus m1 m2, or m2 minus m1 by 1 plus m1 m2. There are two angles. One is theta, and it can be this angle also. You can say phi. Theta plus phi is 90 degrees, 180 degrees. So acute angle between the two lines, you have to take a modulus. And this is what we discussed. We'll do some simple problems today before we move on further. So first question. Find the slope of the line joining A 2,5 and B 1,3. Answer very simple. Slope is y2 minus y1 by x2 minus x1. You can write it as y1 minus y2 by x1 minus x2. That is also okay, because you multiply numerator with a negative and denominator with a negative. So the ratio remains the same. So just remember the order. Numerator is y coordinates difference, denominator is y coordinates different. The order should be the same. Either it is y1 minus y2 by x1 minus x2, or y2 minus y1 by x2 minus x1. Don't change the order. That's all. So y2 is 3 minus y1 is 5. X2 is 1 and x1 is 2. So you get -2 by -1 is equal to 2. So this is the slope of a line. Now, if the slope of two lines, if the slopes of two lines are 1 and root 3. Then find the angle between the lines. Find the angle between the lines. So how do we do this? So what is given? M1 is equal to 1 and M2 is equal to root 3. Okay. So actually you can directly do this. So tan theta 1 is equal to 1. And tan theta 2 is equal to root 3. So this gives theta 1 is equal to tan 45 is 1, tan 45 degrees, and tan 60 degrees is root 3. Okay, tan 60 is root 3. Therefore, this makes angle 45 degrees with the x-axis. This makes angle 60 degrees with the x-axis. Therefore, the angle between the lines is theta 2 minus theta 1 is 60 minus 45, 15 degrees. Got it? Alternative way to do it, of course, that needs some knowledge of submultiple angles, but still we'll do that. Alternative. Tan theta is m2 minus m1 by 1 plus m1 m2. This is m2 is root 3 minus 1 by 1 plus root 3. So root 3 minus 1 by root 3 plus 1. This is, later you will learn, this is tan, this is 15 degrees. Tan 15. Okay, but here I didn't, this was much simple. Theta 1 is 45 degrees, theta 2 is 60 degrees. So difference between them is 15 degrees. Okay. Next. Are you done with this? Can I move forward?
Yes, sir.
Next question. A 4,4, B 3,5, and C -1, -1 form a triangle which is equilateral, right angled, isosceles, None of these. Now use the concept of slopes now. Previously, when we did coordinate systems, we did the same problem using distances. That is also valid. That's also valid. Now let us do this by slopes. Find out slope of AB, slope of BC, slope of CA. That will itself tell us something. Slope of AB, M1, let us call it, is y2 minus y1, 5 minus 4 by 3 minus 4. y2 minus y1 by x2 minus x1. Remember the order. So 1 by minus 1, which is minus 1. Slope of BC, minus 1 minus 5 by minus 1 minus 3. So I have minus 6 by minus 4. This is 3 upon 2. Slope of CA or AC, minus 1 minus 4 by minus 1 minus 4. So it is minus 5 by minus 5 equal to plus 1. Now you observe M1 into M3 is how much? The product of slopes. Product of slopes of AB and AC or CA is minus 1, which implies AB is perpendicular to AC, which implies angle A is equal to 90 degrees. Correct? So which type of triangle it is? Right angle triangle. This is we observed from the slope. We did not observe from distance formula. So this is another way to check. Of course, if the product of slopes is not minus 1, then we cannot say by slopes method. Distance method is the best to identify the nature of the triangle. But this is an illustration of how you can use slopes also. Are you done? Everybody, can I move forward?
Yes, sir.
Okay. Now let us go to equations of straight lines in different forms. Very, very important. The first type, lines parallel to axis. lines parallel to the axis 1. So the equation of a line parallel to x-axis is y is equal to k, is equal to is y equal to k. Equation of a line parallel to x-axis is y equal to k. That means, see, it passes through this point 0 comma k. See, any point on this line will be of the form h comma k. H is variable, but k is fixed. So this is a line whose y coordinate is equal to k. So equation of a line parallel to x-axis is y equal to k. All right. Then what will be the equation of x-axis? The equation of x-axis is, tell me.
Y equal to 0.
Y equal to
Y
0.
equal to
Correct. Equation of x-axis will be y equal to 0. So y value is 0. Next, the equation of a line parallel to y-axis is x equal to h. Equation of a line okay parallel to the x-axis x equal to h. So you can see this, any point on this line will be of the form h comma some k. K will be variable, but h will not be variable. H will be constant. Then the equation of the y-axis is x equal to 0. So this is the first statement, lines parallel to the x-axis and y-axis. Next, very important point, very important form of the line is point slope form. Point slope form. The equation of a line having slope m and passing through a point P x1 comma y1 is y minus y1 is equal to m into x minus x1. Very important form to remember. So we have to find the locus of any point on this line. So let's say P is any point x comma y. This is a moving point. It moves on the line. Oh, sorry, this is not P. This is A. Because P we have already given a point. Let's say P here is x1 comma y1. All right. A is a moving point, let us say. Okay. So in this case, what is the given that slope of this line is m. So slope of line PA is, just see, this is y2 now, y minus y1. So y2 minus y1 by x2 minus x1 by x minus x1 is equal to m. Therefore, y minus y1 is equal to m into x minus x1. That's how you get. Okay, this is how you get this result. Very simple. A is any point lying on the line. So the slope of a line joining 2 points, one point on the line and another fixed point. When you take the slope, it is m. As straightforwardly, you get this result. So anyway, we need two conditions, right, to find the line equation of the line. So given condition is slope is given and a point is given through which it passes. So two conditions. So based on those two conditions, we get the equation of the line. Got it? Next. Oh, very important note. Very important note. The equation of a line having slope m and passing through the origin. And passing through the origin is y is equal to mx. You see here, y1 is 0, x1 is 0. So in this above line, if you substitute y1 is 0, x1 is 0, you get y is equal to mx. Take down. Next, third one. Two-point form. Two-point form. The equation of a line passing through 2 points. A x1 comma y1 and B x2 comma y2 is y minus y1 is equal to y2 minus y1 by x2 minus x1 into x minus x1. This follows from the previous case. How it follows from the previous case? Say slope of line joining AB, A and B. I'll write details. A x1 comma y1 and B x2 comma y2 is M is equal to y2 minus y1 by x2 minus x1. All right. Now equation of the line AB passing through A, isn't it? It is passing through A or passing through B. Y minus y1 is equal to M into x minus x1 from the point slope form. Okay, this is point slope form. In this, you substitute M, you get the result. Okay. These are xy are any point on the line. These are x1, y1 and x2, y2 are fixed points. So 3 forms. One is parallel to x-axis, y-axis. That is one form. Then point slope form, 2-point form. Next.
Sir, can you show the note one, sir?
Which one?
Note.
Previous one? Yeah,
Yes,
this one?
yes, sir.
Okay, take down. Aparajit.
Thank you, sir.
Okay. Okay, next. Fourth one, slope intercept form. Slope intercept form. The equation of the line having slope M and making an intercept C with the y-axis is y equal to mx plus c, a very important equation of the line. I'll explain what intercept is. See, this is called as the point where the line cuts the y-axis is called as the intercept. Mm, this distance, I'm sorry, this particular length is called as the intercept. Okay, the c can be positive. If it's positive, the intercept is above the x-axis. If c is negative, the intercept is below the x-axis. So this is called as the intercept. This is the origin. So since intercept is c, since the y-intercept is c, it means that the line passes through 0, c. Okay, the line passes through 0, c. Since y-intercept is c, it means line passes through 0, c, and it has a slope m. So now it is passing through a point and having a slope. Therefore, the slope, a point slope form of the line, therefore the point slope form of the line is y minus c is equal to m into x minus 0. So this gives y minus c is equal to m into x, which implies y is equal to mx plus c. Okay. Got it? Very simple. Next, these are important results to remember. Each one is an important result to remember. Next, fifth form, intercept form or the double intercept form. We call it as an intercept form. To distinguish between slope intercept, sometimes we call it as the double intercept form. The equation of the line making intercepts A and B with the X and Y axis respectively. Is X by A plus Y by B equal to 1. X by A plus Y by B equal to 1. So this is A, this is B. This A is called as the x-intercept. The line is intercepting the x-axis, this B, and this B is called as the y-intercept. So it automatically means that the line passes through 2 points, A, small a comma 0, B, 0 comma small b. Correct? Any coordinate on the x-axis will be of the form a comma 0, and because this intercept is a, it is a comma 0. If it is, this is y-intercept is b, so this point will be 0 comma b. So proof. Given the intercepts, A and B, it means the line passes through A comma 0 and B 0 comma B. Okay. Therefore, 2-point form of the line or you can do slope intercept form of the line also. Anything you can do. So you get y minus 0 is equal to b minus 0 by 0 minus a into x minus a. Okay, you get this. Now what I do, I'll take this b down. It will be y by b is equal to minus 1 by a times x minus a. In the next step, I write y by b is multiply this minus x by a to minus 1 by a into minus a. That will be plus 1. Minus into minus gives plus, 1 by a into a gives 1. bring this to this side, x by a, this term to the left side. So negative becomes positive, x by a plus y by b equal to 1. So x by a plus y by b equal to 1. Done?
Yes, sir.
Okay. Next form, the sixth form. This is called as the perpendicular form, or the normal form of the straight line. The equation of a line upon which the length of the perpendicular, from the origin onto it. The equation of a line upon which is there, upon which the length of the perpendicular from the origin is p, small p, and the perpendicular makes an angle alpha with the positive x-axis. So when you say x-axis, it means positive x-axis is x cos alpha plus y sin alpha equal to p. This perpendicular form is an important form. In some cases, it is very useful. In some particular problems, it is very useful. So let's see how it looks. The perpendicular form. X, Y, this is the straight line. Now a perpendicular is dropped from it. From the origin okay, this is, this particular length is p. The length of the perpendicular is p. All right, this is the origin. Now let's say the foot of the perpendicular is capital P. This point is capital P. Now we want the equation of the line, but what it is given that this perpendicular OP makes an angle alpha with the x-axis, and the length of the perpendicular from the origin to the line is small p. Okay, proof. Okay, now just look at the proof. Now from the figure, what will be the coordinates of P? The foot of the perpendicular from origin to the line P. The coordinates of the foot of the perpendicular from the origin to the line P is P cos alpha, P sin alpha. Is it not? You drop another perpendicular here. All right. If you drop another perpendicular here, this length, this particular length will be P cos alpha, because let's say this is P Q. This particular, when we drop a perpendicular from P onto the x-axis, this length is Q. So what is cos alpha? Cos alpha is opposite adjacent side OQ by hypotenuse OP. So OQ by P. So therefore OQ is P cos alpha. All right. Similarly, sin alpha is opposite side PQ by hypotenuse OP in this right angle triangle. So PQ by OP is P. So PQ is P sin alpha. So this is P cos alpha, and this length is P sin alpha. All right. So naturally the coordinates of P is P cos alpha, P sin alpha by coordinate systems. Now you got the point. Now you have to find, if you find the slope, then you can do the problem. Now what is the slope? You have found the point. Now what is the slope of the line? Now slope of OP, is, what is that? Tan alpha. Okay, since alpha is the inclination. Now OP is the perpendicular to the line. Therefore, the slope of the line will be m is equal to minus 1 by tan alpha. Why? Since m1, m2, product of slopes of perpendicular lines is product of slopes is minus 1. One slope will be minus the reciprocal of the other. Understand? Since m1, m2 equal to minus 1, m1 will be minus 1 by m2. So slope of OP is tan alpha, and OP and the given line are perpendicular, and the required line are perpendicular. If the slope of the required line is m, then the slope of the required line will be minus 1 times the slope of OP. So that's what we did. And we know that tan alpha is sine alpha by cos alpha. Basically, it is cot alpha. But you write this. Now you know, therefore, the equation of the line with slope m and passing through P is y minus P sine alpha is equal to slope minus cos alpha by sine alpha into x minus P cos alpha. Y minus y1 is equal to m into x minus x1, point slope form. I have just written the previous form, point slope form. Okay. Now you cross multiply this one, you get y sine alpha minus P sine square alpha is equal to minus x cos alpha plus P cos square alpha. Rearrange the terms. Bring this x cos alpha to the left hand side. And bring this to the this side, P sine square alpha. And you take P common. You will get P sine square alpha plus P cos square alpha. So P taken common, you will get this. And trigonometric ratio, standard identity, sine square alpha plus cos square alpha is 1. It's a trigonometric identity for any angle. So you get this. Okay. So this is the symmetric form, say the normal form of the straight line, or the perpendicular form of the straight line. Next. Done? Copied? Okay, I'll share with you the notes So if you have missed something, you can copy it. The next class,
Yes,
all
sir.
okay. The next class, I have another. This is fifth one, sixth one. Now seventh form, it's a very interesting, not so obvious, but very useful in certain problems. It will solve the problem very fast. It is called as symmetric or parametric form of the straight line. Okay. The equation of the line passing through x1 comma y1 and having an inclination theta with the x-axis is of the form x minus x1 by cos theta is equal to y minus y1 by sin theta is equal to r, where r is the parameter. This part is obvious. I'll explain this form. It will be very useful in certain problems. First five forms, we use the maximum in problem solving. These are special forms where in certain locus problems and certain difficult, tricky questions, these two forms, the previous one, perpendicular form and parametric form, they give very short and elegant solutions. So what is this R? Okay, now let us see this. Okay, I'm just putting any line which makes an inclination theta, and it is passing through a point x1 comma y1. So write this as a x1 y1, and now P is any point on this line. P x comma y is any point on this line. Let P x comma y be any point on the line. Now A is already a x1 comma y1 lies on the line. All right, and since theta is the inclination, Since theta is the inclination, slope m will be equal to tan theta. Okay, which is sine theta upon cos theta. Therefore, equation of the line is y minus y1 is equal to m into x minus x1. So y minus y1 is equal to sine theta upon cos theta x minus x1. Bring this theta, sine theta to denominator. Y minus y1 by sine theta is equal to x minus x1 by cos theta. So this is what is this form. But what is this r? Very interesting is this r represents the distance of any point P with from this fixed point x1 comma y1. Okay, so if r is the distance of any point P on the line from a x1 comma y1, then you just see this. From A, I draw a right angle triangle. I draw a horizontal line and then a vertical line. I draw a right angle triangle. Okay. Now this angle is theta. Okay. Let this point be Q. So again, this OQ, not OQ, AQ will be x minus x1. AQ will be x minus x1 because this x coordinate is x, this coordinate is x1. The distance AQ will be x minus x1, which is equal to r cos theta, which is equal to r, this is hypotenuse, times cos theta will give you the adjacent side just by the trigonometric ratio that we did. Then PQ is, just see this, y minus y1, which is equal to r sine theta. Sine theta is opposite side PQ by hypotenuse r. So PQ will be r times sine theta. AQ will be r times cos theta. Therefore, so from here, okay, from triangle, just 2 minutes, I'll leave you after this. We have already crossed 6, but I'll just complete this. From triangle AQP in the figure, AQ is equal to x minus x1 is equal to r cos theta, and QP y minus y1 is equal to r sine theta. All right, therefore x minus x1 by cos theta is equal to r, and y minus y1 by sin theta is also equal to r. Therefore, we can write this parametric form. From this above two, we can write the parametric form. Okay. Also note the coordinates of P are x comma y, right? Which is equal to, what is x? x1 plus r cos theta. From this expression, from AQ, take x1 to the other side, and from QP, take y1 to the other side. y1 plus r sin theta. Okay. So any point P on the line at a distance of r from a point x1 comma y1 will be this. So right now, today's class was full of results. Okay. We have done, like, these are 7 different forms of straight line. The last form is left, the general form of a straight line, ax plus by plus c. Once we do that, for the next 2 or even 3 days, I will just do problems. So next class on coordinate geometry is on Monday, Tuesday, Wednesday. So Monday, Tuesday, Wednesday, we will be doing these problems on these forms. But I would want all of you to go through these forms and come on Monday. So Sunday, you spend some time going through all these 7 forms. You don't have to write the proof, but somewhere in your notebook, you write these 6 forms and understand each of the parameters of this form. And next, when we come, once we know the concept, apply the problem using the concept, and then you will remember. You will remember both the concept and the formula as soon as you apply. All right. Any questions?
No.
Okay. All right. So thank you. So tomorrow's class we will yeah, tomorrow's class we'll continue with functions. All right. Thank you.
Thank you, sir.
Thank you.
Thank you, sir.
Okay.
Yeah.